Ever wondered what it would be like to experience weather beyond Earth's atmosphere? Imagine a world where the temperature swings from blistering hot to freezing cold in a single day, or a place where storms rage on for centuries, dwarfing anything we've ever seen on Earth. Welcome to the world of extreme weather in our solar system. Here, the rules we're accustomed to on Earth do not apply. From the searing heat of Mercury to the relentless winds of Neptune, each planet presents its own unique and fascinating weather phenomena. We'll explore the red spot of Jupiter, a storm that's been churning for hundreds of years, and the colossal sandstorms that engulf the entire surface of Mars. It's a journey that will take us from the familiar to the utterly alien, from the realms of scientific fact to the frontiers of our understanding. Join us as we journey through our solar system, exploring the incredible, the extreme, and the downright bizarre weather conditions on our neighboring planets. Let's begin our journey. Imagine a world where the temperature difference between day and night could melt lead or freeze water. Welcome to Mercury, the smallest planet in our solar system, and a world of temperature extremes. This little planet, closest to the sun, is a place of paradoxes. It's a world where the sun blazes down at over 800 degrees Fahrenheit during the day, hot enough to melt many metals. Then, as night falls, the temperature plummets to a frigid minus 290 degrees Fahrenheit, cold enough to freeze carbon dioxide solid. So what's behind these wild swings in temperature? The answer, my friends, lies in Mercury's lack of a substantial atmosphere. Unlike Earth, with its protective blanket of air that helps distribute heat and maintain a relatively stable climate, Mercury is virtually naked. It has no insulating layer to trap the sun's warmth or shield it from the cold of space. During the day, without an atmosphere to diffuse or scatter the sunlight, every ray hits the surface with full force, superheating the ground. And at night, without an atmosphere to hold in the day's heat, all that warmth quickly radiates back into space, leaving the surface bitterly cold. You might be wondering, what does this all mean for life on Mercury? Well, in a nutshell, it's not looking promising. Mercury's lack of atmosphere and the resulting temperature extremes make it an inhospitable place for life as we know it. Water, a key ingredient for life, can't exist in liquid form here. It would simply boil away in the daytime heat and freeze solid in the night's cold. So, Mercury teaches us that without an atmosphere, life as we know it would be a roller coaster of extremes. It's a stark reminder of just how crucial our own planet's atmosphere is in sustaining life and maintaining a climate that's just right for us. So next time you step outside, take a moment to appreciate the air around you. It's doing more than you might think. Let's go to our second extreme weather condition. What if Earth's storms lasted not hours, not days, but hundreds of years? Imagine living in a world where the weather forecast included a storm that your great-great-great-grandparents would have also experienced, a storm that started before the invention of the telescope and has continued unabated to this day. This isn't some science fiction scenario. It's the reality on Jupiter, the largest planet in our solar system. Dominating Jupiter's southern hemisphere is a colossal crimson cyclone known as the Great Red Spot. This storm has been churning for at least 3 centuries and possibly even longer. Why does this storm persist? To understand that, we need to delve into the atmospheric dynamics of Jupiter. The planet's rapid rotation and lack of a solid surface create an environment where storms don't just form, they endure. Jupiter's atmosphere consists mostly of hydrogen and helium, with trace amounts of other compounds like ammonia, methane, and water. This mix, combined with the planet's intense heat and fast rotation, sets the stage for a weather system on steroids. The Great Red Spot itself is a high-pressure anticyclonic storm, similar in many ways to a hurricane on Earth. However, while hurricanes on our home planet lose strength when they move over land, the Great Red Spot has no such obstacle. Jupiter is all gas, and the storm has an entire planet of fuel to feed on, allowing it to sustain its tremendous power and size. How big is this storm, you ask? Well, it's so large that 3 Earths could fit inside it. That's right, this single storm is larger than our entire planet. And it's not just big, it's also very, very windy. The outer edges of the Great Red Spot churn at speeds of about 270 miles per hour. That's more than double the wind speed of the most powerful hurricanes on Earth. Jupiter's great red spot gives new meaning to the phrase perfect storm, doesn't it? A storm that lasts for centuries, a storm so large you could fit multiple Earths inside it. It's a testament to the amazing and extreme weather that exists beyond our own planet. Now, before we go to our third planet, if you like this video, please like and subscribe to this channel, because we will upload more of these curious facts about our universe every week, so you don't want to miss them. Now let's move to the next one. Can you envision winds so strong they break the sound barrier? Welcome to Neptune, the eighth and furthest planet from the Sun in our solar system. This distant world boasts the title of the windiest planet, with gusts that can reach over 1,200 miles per hour. That's nearly 1.5 times the speed of sound. Now, you might be wondering, why is Neptune so windy? The answer lies in its distance from the Sun and its unique atmosphere. Neptune is about 30 times further from the Sun than Earth, which means it receives significantly less sunlight. This lack of warmth leads to extremely low temperatures, with Neptune's atmosphere dropping to negative 200 degrees Celsius. This chilly environment is a perfect setup for high-speed winds. Let's delve a bit deeper into Neptune's atmosphere. It's largely composed of hydrogen and helium, but it's the methane that makes things interesting. Methane, a greenhouse gas, absorbs red light from the Sun and reflects blue light, giving Neptune its striking blue appearance. But methane also plays a crucial role in Neptune's intense winds. The extreme cold causes the methane in Neptune's upper atmosphere to freeze into clouds. These clouds, combined with the planet's rapid rotation, create bands of high-speed winds. These winds whip around the planet at astonishing speeds, creating massive storms. Some of these storms can last for years, and the strongest can be as large as Earth itself. So, the next time you feel a gust of wind on Earth, consider this. Our planet's strongest recorded wind speed is just over 200 miles per hour, achieved during a tornado. Neptune's winds are 6 times stronger than that, and they're not confined to a small area. They span the entire planet. Neptune is a stark reminder of the power and ferocity that weather can unleash. It's a testament to the extremes that can exist within our own solar system, far beyond the relatively mild conditions we experience on Earth. Last but not least, the last one we show you in this video. Picture a sandstorm so large it engulfs an entire planet. Welcome to Mars, the red planet, a world of extremes, where dust storms are not just an occasional event, but a regular part of the Martian year. These are not just your average sandstorms. They are colossal, planet-wide phenomena that can last for weeks, even months. So, what makes these Martian sandstorms so massive? It all comes down to the thin, dry Martian atmosphere and the planet's elliptical orbit. As Mars moves closer to the Sun, the increased solar energy heats the atmosphere and whips up the dust. This dust, in turn, absorbs more sunlight, heating the atmosphere further and creating a feedback loop that can lead to a full-blown, planet-engulfing dust storm. Now, imagine billions of particles of dust, each smaller than a grain of talcum powder, swirling around in the air, blocking out the sun and plunging the landscape into an eerie reddish gloom. It's like being inside a giant rust-colored snow globe, except instead of snow, it's dust. And it's not just falling, it's swirling, whirling and dancing in the Martian winds. These storms have a profound impact on the Martian landscape. They carve out new features, erase old ones, and continuously reshape the planet's surface. They're also a major challenge for our exploration of Mars. They can damage equipment, obscure vision, and make navigation extremely difficult. But they also offer opportunities for scientific research, providing valuable insights into the planet's weather patterns, atmospheric conditions, and geological history. The scale, intensity, and frequency of these dust storms make Mars a world unlike any other in our solar system. It's a testament to the incredible diversity and dynamism of celestial weather, reminding us that even the seemingly barren and quiet expanses of space can be home to some truly breathtaking and extreme phenomena. On Mars, a simple sandstorm can become a global event. To sum it all up, from Mercury's temperature extremes to Mars' global sandstorms, the weather in our solar system is nothing short of extraordinary. Mercury, a planet of extremes, swings between the searing heat of 425 degrees Celsius during the day and a chilling -180 degrees at night. Jupiter's Great Red Spot, a storm larger than Earth itself, has been raging for centuries, a testament to the planet's turbulent atmosphere. Neptune, the windiest planet, boasts supersonic winds that reach up to 2,000 kilometers per hour. And let's not forget Mars, a planet infamous for its global sandstorms that can blanket the entire planet for months. These extreme weather conditions are not just fascinating, they're educational. By studying these phenomena, scientists can gain invaluable insights into the workings of our own weather systems here on Earth, leading to better forecasts and disaster preparedness. So the next time you're caught in a downpour or a heat wave, just remember, it could always be more extreme. This is the beauty and mystery of our incredible solar system. We hope you enjoyed the video and love to see you again in the next one. Goodbye.